Welcome to KPK Tech World. In this video, I'm going to talk about seven segment LED display, and I'm going to show how I'm going to build the display unit. This part of the breadboard computer, I'm going to build the seven segment LED display. It's time we connect a display unit to our computer rather than counting everything in binary values and then converting with its place value and all that. So I will show, I have actually added a binary counter and an instruction register over here. But before talking about these, I will talk about the 7-segment LED display itself. So this is a 7-segment LED display, and you can see the pin outs of this display over here. So this is in this pin 3 and pin 8, the middle pin of this segment display on top and bottom are connected to ground. So I'm going to connect this in such a way that either of this either pin 3 or 8 should be grounded. So I have connected that to ground, and I'll show you by just plugging in the other pin outlets to the positive 5 volt, and let's see if they power up. So our computer is powered and we have power coming in. So we can see that I'm going to connect this to say 1. So we can see that this segment of our 7-segment display powering up. If I change the pins, so we can see that every segment can be powered by connecting these pins to positive 5 volt. So I have actually done that over here just to show you how it works. We can see that it looks like a H, and what I'm going to do is that we know that our RAM module can store 8 bits of data. By using the memory address register, I can choose between 0 to 15 or 1 to 16 in decimal value, and then I can bring that data to our bus over here, and I have connected that bus value to the 7-segment display. So instead of choosing a decimal value, I will show you something called as hexadecimal. Hexadecimal is nothing but 10 is represented as A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. I will build this using this table. Like for example, I'll show you few values. Say in memory address register 0, this is memory address register 0. I will put a 0. So 0, for a 0 to be displayed in our 7-segment display, we need this paper handy. So we need this segments of our 8-bit value to be appearing in our bus. So to do that, I'll go to our 8-bit data dip switches. So it is, that is 0. We can see that this decimal value, sorry, this binary value is over here in our dip switches, and that is in our RAM, which is now going through the bus. So that is now coming to the our data bus, and from the bus we read that value to our 7-segment display. Now we are going to have multiple displays, and what we are going to do is we are trying to make multiplexing with these displays, and we will only see one value at a time. And I'm going to use to demo, I'm going to use Arduino Nano, and I've programmed this Nano by alternating 2 digital pins, that is digital pin 13 over here and digital pin 11, which will give me alternating signal like a timer circuit, and I'll connect these outputs to the display, and I'll show you how alternating displays will eventually give us a decimal value. instead of a hexadecimal value. I will pause this video for now and I will record these 7-segment hexadecimal data values to our RAM, and then I'll show you again how this data comes to our display unit. I have programmed the values in the our RAM here, and I'm going to show you the values that appear in our 7-segment display. I'm going to start the clock, and we can see that when the binary counter starts from 0, we have our hexadecimal values coming over here. Our binary counter is now 0. It is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that is the hexadecimal equivalent. If we see our chart, 10 is A and 15 is F, and our binary counter pulls the value that is stored in our random access memory, and that is sent to the data bus, and from the data bus we have our data coming to our 7-segment LED display. Now in addition to that, what I'm going to do is I'm going to change these input values from directly from the bus. Instead of the bus, I'm going to connect a Arduino Nano over here. I have programmed this Arduino Nano with timing clock signal that will send us a clock pulse every time, so that we can see the multiplexing in our display. So that works. So we can see that by changing the timing of the clock, we can suitably change the values that is displayed in our unit. I will power off my light so that this looks much better. Say with our clock module, there is a clock actually internally in this Arduino Nano. There are many digital outputs. I have programmed the digital output 13 and 11 to be pulled to the display unit. So if I change the speed of our clock over here, we can see the speed of the data changing. Our computer necessarily works fast, and that display unit appears over here. So I'm again now slowing down the clock, and we can see that we get one display. I will slow down the clock to a sufficient speed so that we only see one digit in 7-segment display. We can see that by doing this multiplexing, we can use the place value of the decimal digits, and I can use multiple 7-segment displays to show value of up to 255, including 0 it is 266, because with our 8-bit programmable computer we can manipulate decimal values of 0 to 255. And this is also a preview of how your mobile phone display or computer display or your TV digital display works. Every time you see a pixel that is timed with a circuit, and there is something like this programmable memory that I'm going to use EEPROM. EEPROMs are nothing but erasable programmable memory chips, and this can store 8-bit data up to 2000 plus rows of data, and that is going to do this store the data of these binary values, and with the memory address like we did in our RAM, that is going to pull the data from the data storage registers and that will output the data to again to the bus basically, and then we will sorry, not the bus, it is going to display the value in our hexadecimal display. So I will build this module over here, and I will show that in the next video. Thanks for watching. Have a nice day.